Fundamental Physics presents an Andrew Young film, Weight versus Mass, or why Weight Watchers should be called Mass Watchers. Gravity. Masses attract other masses. The larger the mass, the stronger this attraction or force is. The Earth's force of attraction is called gravity. Dun, 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 dun. Gravity pulls all objects towards the Earth at around 9.8 meters per second squared. For this presentation, we'll say 10 meters per second squared. The force of gravity on an object is measured in newtons. The force of gravity on 100 grams of mass is equal to 1 newton. Mass is how much matter an object has and is measured in grams and kilograms. Large objects can have the same mass as small objects. Now, which one of these objects has more mass, do you think? The answer is none. Each one of the objects has the same mass of 15 grams. Here you can see we have a rod of polyethylene plastic and a small peg of brass, and as you can tell, they both have 15 grams of mass. Objects of the same size can have different masses. On the scales, there are two blocks of identical size. One is acrylic plastic and the other is copper, and as you can tell, there's a huge difference in their mass. Weight. Weight is measured in newtons. Weight is calculated by multiplying the mass of an object times the force of gravity acting upon it. The formula looks like this. Weight equals mass times gravity. Let's try this out. The mass of the acrylic cube is 19.7 grams, or 0.0197 kilograms. We do our calculation and we come out with about 0.2 newtons. Let's check that against the spring scale to see how close we are. Yep, looks like we're doing pretty good. Alright. Now let's try the same thing again with the copper cube. The mass of the copper cube is a whopping 146.38 grams, or 0.146 kilograms. Again, we're going to do our calculation and we'll come out to 1.46 newtons. Let's check this again against our spring scale and see how we're doing. Yep, looking good. So what does all this have to do with Weight Watchers, you probably wonder? Well, let's find out. This is Ted, and we want to find out how much Ted weighs on Earth. We'll do the same calculation and we'll come out to 700 newtons based on a 70 kilogram estimated weight. Let's take that 700 newtons on Earth and let's see what we figure out as far as what he weighs on the moon. So put Ted on the moon, and what do you know? His weight is different, only 117 newtons. Why is that? Remember, the larger the mass, the stronger the attraction or force is. The Earth is large, and the moon is small. In fact, it only has 1/6 the gravity of Earth. So when we put Ted on the moon, he has less gravity pulling on him, so his weight is less, at only 117 newtons. Now we know Ted's weight changes based on the pull of gravity. So what about Ted's mass? Remember, Ted's mass is 70 kilograms. So let's figure out what he is on the moon. It's still the same, 70 kilograms. Ted's weight changed when he was on the moon, but his mass did not. If he just wants to lose weight, he just needs to take a trip to the moon. But if he actually wants to fit into his skinny jeans, he needs to reduce his mass by eating less donuts. The end. Thank you very much.